Good afternoon. My name is Poonam Rameshbabu, and my 909 project goal is to answer the question, is there a spatial relationship between high PFAS contamination in surface water in Michigan compared to 3 communities of color using 2021 census data? So today I will explain my project goals, data and methodologies, and results of visual and regression analysis that I used to answer the project question. So PFAS are per and polyfluoroalkyl substances. They are a very large group of synthetic chemicals used to make fluoropolymer coatings and products that resist heat, oil, water, and a bunch of other things. So due to their strong carbon-fluorine bonds, many PFAS can be very persistent in the environment, causing contamination in soil and water. And studies have shown that exposure to PFAS can lead to very harmful health effects. So there are thousands of PFAS compounds that exist and are currently being studied. However, the Environmental Protection Agency only has drinking water levels called maximum contaminant levels, or MCLs, for 6 compounds. So for this project, I focused on 2 of the most common PFAS contaminants that are found in water. They're called perfluorooctanoic acid, or PFOA, and perfluorooctane sulfonic acid, or PFOS in short. And really for my project, I focused on visual and spatial regression analysis of PFOA and PFOS values found in surface water and compared them to areas of high minority population, or the 3 communities of color that I chose, which are African American, American Indian or Alaskan Native, and Asian population. The study area is the state of Michigan, and as you can see on this map, these are all the locations of what they're called PFAS sites in Michigan, meaning these are the locations that may have caused a release of PFAS into the environment. I downloaded publicly available PFOA and PFOS surface water results from the state of Michigan and census tract data from the US Census Bureau. So after downloading the data, one of the first steps I did was to map the minority population for the 3 groups. In the first map, you can see African American population. It's concentrated in the southern part of the state, also called as the Southern Peninsula. And I believe historical migration patterns or related to jobs in the auto and manufacturing industry and affordable housing that could have attributed to this pattern of higher African-American population near more urban cities like Detroit, Flint, and Grand Rapids. In the second map, you could see the American Indian Alaskan Native population is relatively higher in the northwestern and northern part of the state. The northern part of Michigan borders Canada and contains several Native American reservations. And I think some of the reasons for this could be economic opportunities back in the day from large mining operations in those areas. And also in the mid-1800s, treaties were signed by the US government designating large areas of land in the Upper Peninsula for Indian tribes, which increased their presence there. The third map shows where the high Asian population are, and again, very similar to the African-American population pattern that we saw. They're concentrated more in the southern, more urban city areas. So using all of that information, I mapped percent minority population by normalizing it with total population, again, because it's only the 3 communities of colors that I chose for the project. And as you could see, Michigan is very diverse, especially because of the higher African-American and Asian population in the Southern Peninsula near urban areas and Native population in the rural Upper Peninsula. That makes Michigan, a very large portion of Michigan, it shows significant presence of these communities of color. So PFAS is a statewide issue in Michigan. I mapped PFOA and PFOS levels of surface water from over 2,000 data points. So on the left is PFOA and on the right is PFOS. As you could see, the higher contamination is kind of concentrated in the more urban areas and also a few locations in the Northern Peninsula. And for this map, PFOA and PFOS currently have the maximum contaminant level set by the EPA as 4 parts per trillion. So the symbols are classified based on 4 ppt. Just visually looking at it, PFOS concentrations appear slightly higher in a few areas than PFOA, but overall they show a very similar pattern throughout the state. So this flowchart shows the step-by-step process I used for visual and spatial regression analysis for the study area, and all the analysis was performed using ArcGIS Pro version 3.03. The first step was to download the data from state and federal websites. Then the data was projected to the state coordinate system and clipped to the study area, which is state of Michigan. After normalizing the data for minority population, I created maps of PFAS contamination and minority population to help with the visual analysis. Next, I performed geographically weighted regression analysis and created 6 different maps to help me understand and summarize the results of regression analysis for the project. So for a visual analysis of how PFOA and PFOS concentrations compare to locations of high minority population, I created 2 bivariate maps, one for PFOA on the left and PFOS on the right. As you could see in the more urban areas such as Detroit, Lansing, and Grand Rapids, and in select areas in the Upper Peninsula, high PFAS concentrations visually do correlate with high percentage of minority population. So I chose regression analysis because it's used to explore spatial relationships to understand factors that may impact observed spatial patterns. And geographically weighted regression, or GWR, allows the regression model parameters to vary across geographic space. So the first step of the regression workflow is to determine the dependent variable, or what needs to be analyzed. In this case, it is PFOA and PFOS concentrations in surface water were my dependent variables. And the independent variables are the 3 minority groups. So a regression coefficient is a value associated with each independent variable representing the strength and type of relationship the independent variable has with the dependent variable. So when the relationship is positive, the sign of the regression coefficient is also positive. And the absolute value of the coefficient helps us understand the strength of the relationship. So higher the value, stronger the relationship. In the next several slides, I will present 6 maps that show the results of GWR for PFOA. So 3 maps for PFOA with the 3 minority groups and 3 maps for PFOS with the 3 minority groups as the model results. So this is the first map, presents the model results of PFOA with African American population. You can see that the regression coefficient is positive. This means that as African American population increased, the concentrations of PFOA in surface water also increased. And there is a east to west, low to high trend, meaning that the western and almost the northern part here have a stronger local relationship between the 2 variables. The second map is PFOA and native population. We can see here that the regression coefficient is negative or very close to 0, which could mean that the relationship is weak, and locally, as native population increased, concentrations of PFOA in surface water decreased. This is PFOA and Asian population, shows a negative regression coefficient. So as Asian population increased, the concentrations of PFOA identified in surface water within those census tracts decreased. So this map shows PFOS model results with African American population. This is kind of interesting because the GWR model shows local variations in the relationship, because the regression coefficient is negative in the eastern and central part of the state, whereas the Upper Peninsula and northwestern part of the state, the coefficient of regression is trending towards 0 or a positive value, which could suggest that there is a weak or negligible relationship. But compared to what we saw with the PFOA model results, although the trend is similar, the analysis does show that there is a more local variation of how African American population relates to PFOS concentrations. Here are the model results of PFOS and native population, negative regression coefficient again, and so basically when the concentrations identified in surface water increased, it was the opposite to what the population was. So when compared to PFOA, although the negative relationship is the same, the trend of the low to high values is slightly different in the lower peninsula, but it's very similar and relatively higher in the upper peninsula, which is where most of the native population, significant native population is located. And I believe areas of similar values or local clustered pattern can represent strong relationship between variables. And the last map is PFOS and Asian population results. They show a negative regression coefficient. So as Asian population increased, concentrations of PFOA in surface water decreased. And there is an east to west trend in the data, meaning that the western part of the state had a stronger local relationship between the two variables again. So in summary, we know that geography is playing a role in influencing PFAS contamination identified in surface water. As seen on the maps, visual and spatial analysis has identified significant spatially clustered relationship between the variables, which are PFAS contamination and the three minority groups. So in conclusion, based on visual and regression analysis, I believe we can conclude that there is a relationship between the minority groups I've selected for the project and PFAS contamination found in surface water in Michigan. These results can be used to understand current conditions of contamination, to affect policy changes, make decisions related to remediation, and potentially predict values or explore other hypotheses related to PFAS in the environment. Now, although I think these results are beneficial to answer the general project question, further analysis is necessary to consider other variables, environmental factors, or even project data limitations. So that concludes the summary of my project, and I can take any questions.